Welcome to my channel. In this video, I'm gonna introduce the main idea behind the substitution rule, and then I will cover two basic examples. First, the substitution rule is the opposite of the chain rule. Let's recall the chain rule quickly. The derivative of f of g of x is equal to f prime of g of x times g prime of x. Which implies that the integral of f prime of g of x times g prime of x dx is equal to f of g of x plus some constant c. As you see here in the left hand side, we have g of x as the inner function. The derivative of the inner function is a part of the integrand. This is the clue to use the substitution rule. When you see an inner function where its derivative is a part of the integrand, then we can use the substitution rule. In this case, we integrate the outer function, then we plug in the inner function in it. Let's cover two basic examples to show you how this works. Example number 1. Let's find the integral of 3x squared times cosine of x cubed dx. As you see, the inner function in this case is x cubed, where its derivative is there as well. It's a part of the integrand. In step number 1, we let u equals the inner function. Then we find the differential of both sides. The differential of u is du. The differential of x cubed is 3x squared dx. Now we replace 3x squared dx together by du. Let's do this in the second step. So again, we replace 3x squared dx by du. The leftover is cosine of x cubed, which is called u now. The integral of cosine of u is sine of u plus some constant c. Finally, we replace u by x cubed, and that's it. We are done. Let's cover another example. Let's integrate 5x squared cosine of x cubed. This example is very similar to the previous one. The only difference, in the previous example we integrated 3x squared cosine of x cubed. Now we have 5x squared instead. The inner function is x cubed. The derivative of x cubed is 3x squared. I don't have 3x squared, I have 5x squared instead. 5 and 3 are constants. We can deal with them easily. Let's see how. Step number 1, we let u equals x cubed. Then we find the differential of both sides. Now, before we move to the second step, let's see which part we need to get rid of. If we look at the integrand, we have x squared dx, and I see it in here. This 3 is causing some issues. We need to get rid of it. This is why we divide both sides by 3. In the second step, I'm going to replace x squared dx by du over 3. The leftover is 5 cosine of x cubed, which is equal to u. 5 over 3 is a constant. We can pull 5 over 3 out of the integral sign. Then we integrate cosine of u du. And in the last step, we replace u by x cubed, and that's it. We are done. Thank you.